In this video, I'll be showing you how to calculate the volume using triple integrals with spherical coordinates. Instead of the typical 3D Cartesian coordinate system, we will be using the spherical coordinate system to simplify the integration process to find the volume using triple integrals. This can be especially helpful to solve the volume of spheres and a small portion of a sphere that's bounded. To convert one from spherical to Cartesian, x equals rho times sine phi cosine theta. Y equals rho sine phi sine theta. Z equals rho cosine phi. Conversion from the Cartesian to the spherical. Remember that r equals the square root of x squared plus y squared. And rho equals the square root of x squared plus y squared plus z squared. So we can conclude that the cosine theta equals x over r, the sine theta equals y over r, tangent theta equals y over x, and cosine phi equals z over rho. For example, to convert x into spherical coordinates, remember that x equals r cosine theta when converting to cylindrical. And r actually equals rho times sine phi. And x will actually equal rho times sine phi times or multiplied by cosine theta. As you can see from the visual, phi is typically bounded from 0 to pi. The bounds of theta are typically between 0 and 2 pi. Rho dictates the distance from the z-axis to the point P. So as you can see from the video, the sphere is getting bigger and smaller. To find the volume like we typically do with Riemann sum, we will be partitioning some region D into spherical blocks formed by the dimensions of the change in rho and the rho times the change in phi and r times the change in theta. Remember that r equals rho times sine phi. Replace r with rho times sine phi in the equation so that the change in v equals the change in rho times the change in phi, and rho sine phi is multiplied by the change in theta instead of r. So we can conclude that our dv, or our change in v, equals rho squared sine phi times the change in rho times the change in phi and times the change in theta. Based on this information, we can conclude that to find the volume using triple integrals with spherical coordinates is the triple integral of some region D, f of rho and phi and theta times its corresponding dv value. And this really just equals to the inner integral with respect to rho from g1 of phi and theta, which is the bottom surface, to the top surface, which is the upper bound, g2 of phi and theta. Our middle integral will be with respect to phi from the min phi to the max phi. Usually the bounds for phi will be between both 0 and pi. And the outer integral will be with respect to d theta. That will be from alpha to beta. Note that you should really make sure that you're setting up the bounds correctly. You should convert the equation you are given into spherical coordinate first, and be careful of your bounds. And remember to draw a picture if you need one. I hope my video was helpful in your understanding on how to calculate the volume using triple integrals in spherical coordinates. Thanks for watching.